This is the Databricks Data Engineer podcast. There's one call Spark makes about your joins that either finishes your pipeline before standup or kills the job outright. By the end of this, you'll know when Spark should make it, when it shouldn't, and the question that tells you which. It's the broadcast join. Start here. 2 engineers, same team, same big orders table, same lookup table. Sarah's version finishes in the time it takes to get coffee. Mike's version dies. And the error isn't about the data at all. A task ran out of memory, building a hash map. Same cluster, same tables, one line different. So what was in that line? Stay with me. The answer is one sentence, and it changes how you read every join. Forget Spark for a second. We're on an office floor. Picture 100 desks. Each holds a stack of order records, a slice of one very big pile. Every order needs matching to a product name, and those live on one short list of product codes. 1 page, 2 ways to get that done. Option 1 is the meeting. Everybody picks up their stack and walks to a conference room, and it gets sorted by product code, so matching records sit together. Everyone moves. Nothing happens until the last person sits down. That's the shuffle. Both sides halt across the network, so matching keys land in one place. Option 2 is the memo. The short list goes out to the floor. Nobody walks anywhere. Nobody waits. Every desk matches at its own seat, at the same time as every other. That's the broadcast join. The small table lands on every executor, the memo and the meeting. That's the whole model. Right? Because the version that gets passed around isn't a model, it's a TP. Broadcast equals fast. The checkbox you flip when a join runs long. Sound familiar? And a tip with no model is how Mike's job died. So let me break what I just taught you. The memo has a cost, and it isn't where you'd look for it. Here I have to correct something you've almost certainly read. The standard explanation says the small side gets hauled back to one desk in the middle, assembled there, and handed out. That was true, and on a runtime old enough it still is. On anything current, on Databricks, it hasn't been for years. What actually happens is that every desk runs its own copy, at its own seat, before it can match a single record. And that copy comes off the same desk surface they were using to do the work. That's why Mike's failure named a task and not a table. Second thing, the number lies. How does Spark decide? It compares an estimate of the small side against a threshold, about 10 megabytes out of the box. Under it, memo. Over it, meeting. Keep out of the box, loose. Adaptive execution uses a more generous one later, once it has real numbers. Here's the problem. The number Spark checks is basically the size of the files on disk, compressed columnar, packed as tight as Parquet can pack them. What every desk builds is the unpacked version, deserialized into a hash table in memory. A memo that's 1 page in the filing cabinet becomes a fat stapled stack the second somebody unfolds it to read it. So the question was never, is this table small? Stay with that. It's the shift. Small isn't a property of the table. It's a property of the table unpacked, next to the work that desk is already doing. Now you're probably thinking, fine, but adaptive query execution handles this. Databricks replans at runtime. Partly right. Honestly, it's one of the better things that's happened to Spark. It lets a join start as a meeting, looks at what actually showed up, and flips to a memo mid-flight if one side is tiny. Measured, not guessed. Although, careful. What it measured is the packed size coming off a shuffle. Better than the guess. Still not the size of what each desk has to build. And notice where its hands are tied. It can promote a meeting into a memo. What it can do is measure a side it never shuffled, or argue with a hint. And some of you are already thinking, so I'll just put the broadcast hint on it. Sure, the hint is you overruling the estimate. When you're right, It's the best line you write that week. When you're wrong, you've told 100 desks to each build a 1,000-page document before they can start working. And you switched off the guardrail build to stop that. So why is the default so timid? 10 megabytes is nothing. Because the two failures aren't the same size. Miss a broadcast you could have done and the job is slower. Annoying, usually recoverable, you fix it Tuesday. Broadcast something you shouldn't have, and the task falls over at 2 in the morning. Every table downstream of it is still yesterday's data when people log on. The threshold isn't a performance setting. It's a blast radius setting. So what do you carry out of this? 2 things, and they get names. Tool 1. The photocopy question. Before you reach for a broadcast, ask yourself, would I hand a copy of this to every desk on the floor? Not, is the file small? That question drags you to what matters. The small side after filters, unpacked, in memory. And you can see that number. Run the query once and find the broadcast node, the Spark UI on a cluster, the query profile on serverless. The data size on it is the actual payload. A lookup table of product codes. Copy it, obviously. 6 months of events you're pretty sure filters down to almost nothing. That's the one that kills you. Pretty sure it filters down is a guess, and you just BT every desk on the floor on it. Tool 2. The who fell over question. When a join misbehaves, don't start with the data. Ask which strategy is in play, then ask who fell over. 2 tells. First, the stages finish and the whole thing sits there. Minutes later it dies, complaining it couldn't finish broadcasting in time. Look at the small side. Too big or too slow to produce. Second tell is the one worth memorizing. A task dies out of memory while it's building a hash map. That's a desk on the floor. That's your broadcast. And if it's the driver that fell over, on Databricks, that's a weaker signal than it used to be. A collect hauling a result setback is the usual culprit now. Broadcast is still on the list. Non-equi joins still route through the driver. It's just not the first name I'd check anymore. Either way, the question is the same. Did anything on the small side get bigger since the last green run? And the plan tells you which one you got. Look for the word broadcast in the name of the join. That's the memo. No broadcast, you got the meeting. This is one of those topics where the depth is audible, which is why interviewers love it, I think. Your plan shows a sort merge join. Why didn't Spark broadcast? The table's too big is true, and it's where most answers stop. It's over the broadcast threshold is better. Here's the one that changes what they're writing down. The estimate Spark checks is roughly the compressed size on disk. What gets built is a hash table in memory. And on Databricks, every executor builds its own, out of the memory its tasks need. So the real question is what that table costs unfolded, times every executor. So, back to Sarah and Mike. Sarah had looked at that join too, not at the file listing at the table, and she wasn't handing that to every desk on the floor. So she left it alone. Spark called the meeting. It finished. Mike had run the same join the week before and watched it eat the whole coffee break. The same coffee break Sarah had decided she could live with. He figured it could be quicker, which is fair. So he put the broadcast hint on it, because the file listing said the table was small. What the file listing didn't say was that the product code list had stopped being a code list. A description column had been added to it. It was a catalog now, folded, still small. Unfolded onto 100 desks, it was a phone book. That was the obvious copy it case, right up until a column got added to it. Small was never a property of that table. It was never a Spark mystery. It was a memo that should have been a meeting. That's what I've got for you today. So, 2 questions. The photocopy question before you broadcast. Would I put a copy of this on every desk on the floor? If you hesitate, that's a meeting. And the who fell over question after it breaks. A task out of memory building a hash map is a desk on the floor. That's your memo. And I think that's the actual dividing line. Not knowing broadcast joins are faster. That's on every tip list there is. It's knowing the shape of the failure, so the speed is a decision you made instead of something that happened to you. If this made broadcast joins click, send it to somebody on your team who's about to reach for that hint this week. The photocopy question takes 10 seconds. The phone book takes down the overnight run. See you next time.